So the final discussion we're going to have today is going to introduce you to a really cool helper class that I wrote called the AsyncTaskBarrier, which is a framework that's useful for demonstrating how asynchronous processing works in Project Reactor. So we're going to show how the AsyncTaskBarrier framework can be used for Project Reactor. There's implementations for RxJava as well that are slightly different because the APIs are slightly different. So when we take a look at the case studies that use big fractions, we're going to see that they're divided up into a couple different chunks. There's some ones that use synchronous processing, so they will block, and I just do that as a starting point. That's not really the cool thing about reactive streams. We just need to start somewhere. We don't want to introduce all the topics at once, so we start out with the simple synchronous processing. But then very quickly we get into the asynchronous processing. And you see the way the asynchronous processing works is they use these methods like subscribe on or publish on, and that will then direct the computation to run in a background thread somewhere, which is cool. The problem there is that when you start doing things in the background, then the computation method will return right away while the thing is running in the background. And that could cause some problems. In particular, if we're not careful, we're going to have the program fall off the end of main, which will then cause all the threads to shut down, which is not a good thing. So what we're going to do instead is we're going to define a single location we can use in our main test driver program that can set all the asynchronous computations running in the background and then have a single point to wait for everything to finish, which is actually very similar to the completable futures collector stuff we talked about that appeared on the quiz. If you remember, it was called future collector int stream or one of those variants. Very much kind of like the same idea. And here's how this thing is going to work. We're going to have a way to use the asynchronous task barrier to register methods that we want to run asynchronously. So here we're going to use AsyncTaskBarrier register. This is obviously a static method, and we're going to give it a method reference. So it's going to register these three method references: test fraction reduction async, test fraction multiplication callable, and test fraction multiplication callable 2. Those are the three methods we register. All of those methods run asynchronously. They do not block. They start the computation and they return right away. And then what we're going to do is we're going to use this cool little single point to wait for everything to finish. By the way, this framework also works for synchronous computations, but that's not the interesting part. The interesting part is the asynchronous computations. So what's going to happen here is when we get done registering all of our methods we want to run asynchronously, we will then tell the AsyncTaskBarrier, please start to run the task. And what that does is that returns, in this particular case, a mono, which will emit when all the asynchronous tasks are finished. So remember that futures collector we had? It's kind of the same sort of idea. And then since we're here in the main program where we have nowhere else to go at this point, we're going to say runtasks.block. And .block is very similar to the join method with completable futures, where it'll basically say, okay, do not pass go, do not collect $200, stay here until those asynchronous computations are finished. So it basically plays the role of a barrier synchronizer that will hold the main thread, the calling thread, until all the other asynchronous processing. So the question is, can you have more than one async task barrier? In this particular implementation, there's just one per process. And that was just for simplicity. I was just using it for this. To answer your question, if you had a need to have more than one of them, it would be very easy to change this to get rid of the static variable. So you'd have an instance variable that would keep track of all the state, and then you could have multiple instances of AsyncTaskBarrier, which would be easy enough to do. And since the source code is available, it would be easy to change it. So the AsyncTaskBarrier provides a framework that will run tasks either synchronously or more likely asynchronously, so then it's more interesting. And it ensures that the calling thread that invokes the method, basically the one that calls run tasks followed by block, doesn't exit until all the asynchronous processing completes. That's the secret sauce of AsyncTaskBarrier. And after we've covered a whole pile of Project Reactor operators in much, much more detail for fluxes and monos, we will return and explore the implementation of the AsyncTaskBarrier. It's really, really, really cool. But it wouldn't make a whole lot of sense to look at the implementation now because you wouldn't understand what any of the methods do, and it would just be confusing. But we will cover it before the class is done, before the course is done, and you'll get a chance to see how it all works. I had a lot of fun implementing this, and it is a very, very useful tool for debugging your programs, because otherwise you have to do all kinds of wacky things with like sleeps and timeouts and stuff like that that is distracting from the task at hand. So that's the end of the overview of the Project Reactor Async Task Barrier framework.